Okay, what I want to do is I want to get back to this problem 48. Tried different ways to work this problem, and there's probably an easier way, but this is one way that will work. Notice what we did. We took the left side, and I rewrote tangent of A plus B, tangent as sine over cosine, same thing on the bottom. And then this is a complex fraction, so I rewrote it as the bottom fraction flipped. And then what I did is I used the sum of difference identity to write out the sine of A plus B. There it is right here. Cosine A plus B, cosine A minus B, sine of A minus B. And then we have a huge FOIL problem. In other words, it's a binomial times a binomial over a binomial times a binomial. Okay? Okay, after a whole lot of writing, this is the first, this is the outer, this is the inner, this is the last, this is the first, this is the outer, this is the inner, this is the last, okay? Now notice what happens when you multiply together. Here you get a cosine squared B, a sine squared A, cosine squared A, and sine squared B. Also notice that we have a couple parts that are repeating. Sine A, cosine A, sine A, cosine A, sine B, cosine B, sine B, cosine B. So you could rearrange the terms and factor out. So that's what this part is right here. Here, I factored out a sine A, cosine A from this part and this part, and I'm left with sine squared B plus cosine squared B. I did the same part with the remaining two terms on the top, and then on the bottom I did the same thing. Again, notice here we have a sine A, cosine A, and here we have a sine A, cosine A. I'll be left with cosine squared B and sine squared B. Now, the $20 million question is, what do you notice here at the bottom? Well, we know that sine squared plus cosine squared of the same angle, that's just 1. Sine squared cosine squared is 1. Sine squared cosine squared is 1. Sine squared cosine squared is 1. So let's rewrite this. It would be sine of A, cosine of A, plus what? Sine of B, cosine of B, all over what? Sine of A, cosine of A, minus sine of B, cosine of B. Okay, that was a lot of work for problem number 48, but we did push through, get that part done. Okay, rolling right along here for this next section. Notice here that this looks familiar, and that's a double angle for a cosine. So the right side is given to you, we just have a number 28 instead of theta. That would equal to cosine of twice that angle, cosine 2 theta, or cosine of 2 times 28, which is 56 degrees. All right, now the next one, number 5, it looks like this identity here, 1 minus 2 sine squared theta. So that's the same thing as, again, cosine 2 theta, or cosine of twice 17, which is 34 degrees. All right, let's try that again with number 7. Number 7. Cosine squared minus sine squared, yes, that's this guy right here. So it's going to be cosine of twice that angle. Well, what's double 9x? 18x. And then lastly, number 9. For number 9, I have something that looks a little familiar with the double angle identity for sine. May help to rewrite this 2 times 2 sine of 8x cosine of 8x. Okay, now remember, this is theta, okay? This 2 I'm just going to copy down, and then 2 times this is just sine of double the angle. Sine of double the angle. 8x doubled is 16x. So that would be my answer right here. Okay, so that's how to work those problems. Okay, this is a bit of a tricky problem. If secant is equal to 4 and we're in quadrant what? 2, so I'm just going to draw a little picture here. Quadrant 2, here's an angle right here. Okay, remember this is really my x, right? Okay, so the secant is 4, so the cosine will be 1 over 4. Adjacent over hypotenuse. 16 minus 1 is 15, that's radical 15. Okay, it wants to know, find the exact value without solving for x. So the first one is sine of x over 2. It's half the angle, half the angle. Well, we know half that's going to be in quadrant 1, so we just know it's going to be positive. Now, I have a part of your green sheet that maybe I need to make a minor adjustment to. I thought about doing this, but I'm going to rewrite this as a radical 1 minus cosine of 2 theta, or 2x, over 2. Okay, now do keep in mind that if it's a quadrant between 90 and 180, half of that angle would be in quadrant 1 there, which would be positive. So I'm just going to use the positive side. 1 minus cosine of 2x. Well, cosine of 2x is this angle over here, okay? Well, that's x, right? This should just be x. Okay, I always seem to get myself a little confused here. This is just cosine of x, because that's double this angle. Anyway, cosine of x is 1 over 4. This is over 2. Now, we just got to play with working this out, and each radical is a little different. I'm going to say 1 minus 1/4 is just 3/4. 3/4. That's over 2. And you may remember, I don't know if I told you this or not, but to take half of a fraction, half the top would double the bottom, to double the bottom. So that's just going to be square root of 3 over 8, which is radical 3 over radical 8, which is radical 3 over 2 radical 2, radical 6 over 4. Okay, that would be the answer there. Now you can check this by finding out this value of the angle here using your calculator. Then just take half of that angle and find the sine, and it would work out. Again, you have the half angle for cosine. It's the same thing, but the sine is just plus. And then the tangent for the half angle formula is the one over the other. Let's just set it up. So what would the tangent of half the angle be? Okay, it's just going to equal to, first of all, tangent's positive there, so it's going to be positive. A radical over radical. So the top would be what we just got done with, 1 minus 1/4 over 2, and the other one would be 1 plus 1/4 over 2. Okay, you'd have to clean that up a little bit, but that's how to do that problem. Okay, now we have approved the identity. We're just going to do the even one. The question is, which one's a more complicated side? I like that question. I'm going to start with the left side. Now remember, it's sine squared x minus 1 squared. Okay. Now you could use the Pythagorean theorem, but I'll give you a shortcut how you could do this in your head every single time and not miss. To square a binomial, you square the first, you square the last, you multiply these two together and double. Works every time. So what we're going to do is we're going to square the first. The square of sine squared is sine to the 4th. We're going to multiply them together. What's 1 times sine squared? It's sine squared. Minus 2 sine squared x. And then we have a plus 1. We recognize that we recognize from a formula 1 minus 2 sine squared x is the double angle identity for cosine. That's equal to cosine of 2x. So I'm going to rewrite this as cosine of 2x plus sine to the fourth x. Okay, and that's equal to what I was asked to do over here. Now, how am I doing these problems? Well, of course, I've done these before quite a lot, but you know the rules. I gave you the rules in a little handout, and then I explained the rules where I call learn the rules. Okay, learn the rules, and that will help you out. And I work problems, so that's how you do that. Okay, now we have another identity. Now, don't want us to have a crisis here, otherwise we'd have an identity crisis, right? Well, how are we going to do this? How about we start with the left side, okay? 1 plus cosine of 2t. Cosine of 2t. I'm not exactly too sure. I'll just write that here, cosine of 2t. Then on the bottom I have the sine of 2t minus cosine t. This is we're going to have to work with this guy. Now, I do know that the bottom would be twice sine t cosine t, and then I'm going to put over here minus cosine of t. Okay, so I do kind of get that. On the top, I'm left with cosine. So I wonder if I could use the double angle for cosine and do the cosine one, which is cosine squared, 2 cosine squared minus 1. All right, now let's play with that for a second. The top is just going to be left with 2 cosine squared t, and the bottom, hey, could I factor out a cosine t? What would I be left with? 2 sine t minus 1. Now I am mighty close to what I have here. Oh, but wait a minute. I know that x squared over x, these x's divide out and just left with x at the top. And I see a cosine squared and a cosine t at the bottom. So I'm going to mark that out and mark a little 2 out. So then I'm just going to have 2 cosine of t over 2 sine of t minus 1. And lo and behold, that is exactly what I was looking for. So again, a little of experience, a little bit of creativity. You could do these identity problems. I certainly wish you well while you're doing these.